Welcome to the second part of the cognitive science intro lecture. This is a little bit of a thought experiment that we're going to be talking about now. So here we go. All right, we've gone back in time. Very cool. To meet Newton, the Newton, not Fig Newtons, Newton. And we're going to show him, wait for it, a microwave. Okay. We're like, this isn't so cool, right? This is everyday stuff. But he is fascinated. Okay, so he decides he absolutely has to figure out how this thing works. How does it cook food? That is his scientific question. How does it cook food? So he decides to take, there's that word again, an interdisciplinary approach. Okay? So he starts brainstorming. Maybe there's a fire inside. Maybe it harnesses the sun's power. Maybe it sucks power up from the core of the earth to cook food. So based on the different subdivisions, the different approaches that we were talking about in the first lecture, what approach do you think this is most akin to? Like, what do you think this is most similar to? It's going to be philosophy. Okay, we're making theories based on observations alone. We are guessing about how this could work based on our current knowledge, right? Okay, so now he decides he's going to test the performance, test and retest. What does it do well? What kind of foods will it cook? What won't it do well, right? What is going to make it like explode and spark and other things, and what does it do to different textures of foods? And if you haven't tried this PEEP experiment, please do. It's really fun. And like what cooking times do you need for different foods, for different things? So he documents these results. He's got data now. He makes new hypotheses and he tests these hypotheses and then retests these hypotheses. And this is going to be most like psychology. Okay, so now he decides he's going to open up the external casing. Okay, what's in here? What is this thing made out of? So he notes the structure of all of the internal bits and pieces and doohickeys and things, right? What is this most going to be like? The structure of things and how they connect. This is probably similar to neuroanatomy and neurophysiology. Okay, we want to look at how the brain is built and how the different structures of the brain connect to each other and communicate with one another. Okay, okay, next. He decides, okay, now that I know what parts are here, I'm going to start pulling parts out and see what happens. If I take this one out, does it work? Does it still cook food? Does it turn on? Does it, what about this one? Does it function? Does it function as well? So he's removing parts, noting what happens when he takes these parts out. It's going to be most like neuropsychology, right? We lesion parts of the brain in controlled lesion studies, not with humans, don't worry. We look at already brain damaged patients and try to infer what's going on based on the damage that they have. Okay, so finally, Newton decides, I'm going to build a model. Okay, and so he does, and here's his little cardboard model and his cute little model hamburger, and I think that's a pizza back there, right? Does a really great job. This is going to be most like engineering and robotics. And I'm not trying to equate engineering and robotics with cardboard by any means. What I am trying to say is that with engineering and robotics, we work with what we have in order to simulate that which we want to study, right? So we work with what we have in the sense of neural networks, computational neural networks, man-made neural networks that are meant to simulate via computer machinery what's going on in the brain. Okay, because the computer machinery is the closest thing that we have to be able to build a model of something like the brain. So, okay, so Newton, he's done all this stuff. What do you think? Do you think that he's going to succeed in answering the question, how does it cook food? Pause for a moment. Okay, I'll give you my 2 cents. I don't think that he's going to succeed. No, because here's the deal. See, we've gone back in time. We haven't brought Newton to our time, right? So we're in Newton's time. Newton doesn't know about things like, vibrating air molecules and how they create heat, right? He doesn't understand that essentially what you're doing with a microwave is radiating the water molecules in food such that the food heats up, right? That's essentially what you're doing. But he doesn't have the basic understanding of these scientific principles because we haven't gotten there yet. He hasn't gotten there yet in his scientific understanding of the universe. And that's okay because in science, the idea is progression, right? And likewise, we have to progress in our study of the brain. So, do I think that we are going to succeed in answering our question, how does the brain work? Probably not in my lifetime, and I would venture to say probably not even in your lifetime. And I know that this sounds kind of depressing, but forward motion is what science is all about. And we have to constantly be outdoing ourselves. And in 100 years, we will have a more sound fundamental understanding of the universe. And that will allow us to answer our questions about the things in the universe better, right? So I think it's a long time coming that we understand exactly how the brain works. But that just means we have a lot of work to do, and the work is pretty fun. So that's it for this thought experiment talk. Feel free to discuss this in your interaction topics. It is a good interaction topic. And it's good to think about. It's good to ponder. Okay, enough deep thoughts for today. I will see you guys in our next lecture.